Welcome to myprojectbazaar.com. Now we are going to discuss about the product image processing based method to assess fish quality and freshness. Now we discuss the abstract for the process. In this process, an image processing method which is completely automatic, efficient and not destructive for segmentation of tissues and predicted for freshness of fish samples. The gill tissues of the fish samples are automatically segmented by using the k-means clustering method based on the features are statically extracted in the wavelet transform domain using the Haar filter. Here one of the most important technique is the KNN classification to classify whether the fish sample is quality or not. First and the second level decomposition of the wavelet is performed and then the coefficients obtained at each levels have been analyzed predicted the freshness of the fish samples. So here we have the input, clustering, feature extraction, then classification. The input is taken from the dataset and the clustering result will segregate the Gills regions from the other backgrounds and hence the feature extraction is done to extract the required data from the image and the classification is performed to classify whether the input is eatable or not. Here the KNN is more suitable and flexible to classify whether the input is eatable or not, and then the performance is estimated by using the accuracy, sensitivity and specificity, and then the results are shown in the figures and the estimations of the process is justified by using the graph plots. Now we are going to discuss about the flow diagram for the process. At first the input image is taken from the dataset. The dataset is the folder which consists of the several input fish images. When I take the input image from the dataset, the pre-processing is carried out. If the process wants the pre-process means it will include the resize and Gaussian filter. But here we need not to apply the resize and here we use only the real-time datasets. So the noise is not present in the datasets. So once I applied the pre-processing, the segmentation is carried out. In the segmentation part, we use the k-means clustering for the fish segmentation. By using the k-means clustering, the gill region is separated from the fish and the other backgrounds will be eliminated. After extracting the gill regions, that is the region of interest, the feature extraction is carried out. In the feature extraction module, we have the three type of feature extraction. The first one is the DWT by using the Haar wavelet. Then we use the mean and standard deviation to extract the feature from the Gills regions. After extracting the features from the image, the classification is done by using the KNN classification method. In the KNN classification, we have the three type of input. First one is the test feature, train feature and then target. The test feature is taken from the input image and the train feature is the feature which consists of the 16 dataset images, and then the target is the classes like whether the food is eatable or not, and then the estimation is carried out by using the accuracy, sensitivity and specificity. By these parameters only we have justifying the process is whether the process is efficient or not. Now we discuss the initial running procedure for the process. At first open the MATLAB 2013 and change the current directory. If you want to execute the code means just right click in the main.m file and select the option run. Now you can see the dataset folder. Open the folder dataset and select any one image from the dataset. After the selection of the image, click the button open. Once the button open is clicked means the selected image is processed automatically. Now the input image is shown in the figure 1 with the title input image. This is the selected image. Then the input RGB image is shown once again. Then this is the result for the k-means clustering. The first image represents the index image, that is the labeled image. There are three type of labels. First one is the white, then the second one is the black, then the third one is the gray shaded label. The cluster 1 is shown in the subplot 2 with the title objects in cluster 1. The cluster 2 is shown in the subplot 3 with the title objects in cluster 2. Then the cluster 3 image is shown in the subplot 4 with the title objects in cluster 3. Then we have seen the Gill region in the cluster 3. If I see the cluster 3 means, just go to the command window and enter the option 3 and click the button enter. Now the selected cluster is shown in the figure 5 and the corresponding features are extracted from those region. Now I will show the result one by one. Now this is the selected cluster region, that is the region of interest. Then the features for the low region, that is by applying the DWD, the low region is applied. This is the results for the low region. Then low high region. Then this is the result for the high low region. Then this is the result for the high region. So after extracting the mean value for the low high low and high value, we have to apply the standard deviation value for the low region, then low high region, then high low regions. After that, at last, the standard deviation value for the high region. Then the variance is applied for the low like the previous feature extractions. Then here we using the low high frequency features extractions, then as well as the high low, then high features. Then the local binary patterns, that is the pattern extraction from the region of interest is applied. Then the test feature values is concatenated by concatenating all these features extracted from the region of interest. Then the performance estimation is done. Then this is the performance estimations: accuracy, error rate, sensitivity and specificity. These are the estimation parameters finding here.
Thanks for watching this video.